So Brian asked me to, as he said, give a slideshow on living with frozen ground. And I thought about this for a while. It's been 1998. Changes have occurred. Climate change is occurring. And I gave it some retrospective thought, and thanks to a colleague of mine as well, came up with the title, Living with Thawing Ground. So I'd like to introduce this to you today in terms of Yellowknife and an understanding of the conditions which we're faced with today within discontinuous permafrost and communities that reside within them, and in particular Yellowknife. Just two diagrams for some takeaway messages. Number one will be at the beginning, science priorities for risk assessments and adaptation solutions. Some basic premises, some things that we need in order to deal with permafrost and its effects on infrastructure, a good understanding of the thermal state of permafrost. This means understanding how it's changing through time and understanding where you reside in terms of, are you in cold, is it cold, is it warm, where are we waiting for it to thaw? And the physical state of permafrost that goes along with this. Is it solid? Can we put an infrastructure on this? Is it creeping? We need to understand the physical and the thermal state of permafrost. In addition, very importantly, the interaction between permafrost and infrastructure and the effects of the infrastructure in turn on the permafrost in a changing climatic regime. Yellowknife has its beginnings, I believe, in about a long way back, but in terms of settlement, southern settlement, about in the 1930s, and in fact, a significant thing happened in 1938. Gold prices went from $28 an ounce to $35 an ounce, making it economically viable to begin gold production in Yellowknife. So back in 1941, there were a little over 1,000 people living basically on Latham Island and Old Town. In 1967, Yellowknife became the capital of the Northwest Territories, and the population skyrocketed to 3,500. Today, the population is almost 20,000. 45% of the population of the Northwest Territories resides in Yellowknife. Interestingly enough, too, its economy is changing, of course. Look back to 1951. Whoops, sorry about that. 1951, dominated, of course, by mining, gold mining. 1951, population 3,000. Wow, most of you were working in the mining industry, and they were just down the street from where they lived. Now that has changed through time, of course. You've gone from gold to government with the transition in 1967. And in fact, too, today, look at what's changed, too, in terms of things. When I was here in 1998, and I lived here, it was our gold is paved with streets. And today, you see on the cover of your takeaway package, the diamond capital of North America. Now, interestingly enough, if you're in the mining industry today and you're involved in the diamond mining industry, you either are administratively living in Yellowknife or you're flying to the mining site. Essentially, it's become a sleeper community if you're actually coming in and out of mining. My point is, with the change in economy that has gone on and the growth of Yellowknife, there's an expectation that goes with this. You know, we want our Timmies and we want our drive-through. And we're going to drive on paved streets with utilities, with water, sewer piped under the ground, and we're going to be able to build our houses and live in comfortable style. That's kind of what it's like. But, of course, the reality is we live in the north, and we live in a zone of discontinuous permafrost. This area where we live is what we call widespread discontinuous. Simply means that if we go farther south, where we find permafrost will be mostly in peatlands. It will be the peat that contains the permafrost. When we get up here a little farther north, essentially, if you're not on rock, if you're not under a lake, and if you're not next to a swamp, you have permafrost. It means that deciduous forests, conifer forests, and peatlands all contain permafrost. There's actually a fair amount of permafrost in this region. Now, as we've heard already, permafrost is a temperature condition of the ground. This is what permafrost people like to tell you. Essentially that it's defined as soil or rock that remains below 0 degrees Celsius throughout the year. Indeed, there is an active layer that freezes or thaws in the summer. Of course, in the south, that's the only part that freezes, but in the north, there's a layer of frozen ground all year, which could be, in the Yellowknife area, up to 80 meters thick. From a practical perspective, however, permafrost represents potentially unstable material that contains ice, or that can contain ice, that is sensitive to the impacts that are caused by natural processes, human impacts, and climate change. This is the air temperature, the mean, these are annual mean temperatures at the Yellowknife Airport since the 1940s. And as you can see, on a regular basis over the last 40 years, air temperatures have been rising. And this rate of increase is 0.6 degrees per decade, 2.2 degrees in the last 40 years. This value here, and it could be debated as to where to put this, but Roger Brown placed a essentially threshold in regards to the long-term air temperature conditions that would sustain permafrost globally at about minus 3.3. And Yellowknife has persistently crossed this threshold on a regular basis in the last decade, and not by a little bit, but by many degrees. And essentially, whereas the average air temperature right now is minus 4.6, I believe. Where we reside right now and where we're moving to is minus 3.3 and warmer in the coming decades. These are ground temperatures, so in the top approximately 10 meters. And there's a zero line there, so you can see they're all negative, essentially, mostly. Ground temperatures that you will find if you go outside of the city to peatlands or spruce forests or birch forests, these range of conditions that you will find outside of Yellowknife in the ground. Basically, about minus 0.5 to minus 1.5 in undeveloped terrain. The black lines are ones that we find near water bodies where there's a warm influence adjacent to that. And those temperatures are less than or warmer than minus 0.5, verging minus 0.2. Warm permafrost, of course. These are temperatures that we find within the developed terrain in Yellowknife, beneath walkways, roadways, highway shoulders. Only two of the ones that are shown here approach the colder temperatures that you see in the undeveloped terrain. Most are quite a bit warmer, minus 0.5 or warmer, much like the ones that you see adjacent to warm water bodies. So what's going on? It's the added addition of the infrastructure, removing that vegetation cover and disturbing the terrain, essentially warms it up by about a degree. In addition to this warming that we might see from climate change. We'll see. Third point, because of the history of the region, which involved a large glacial Lake McConnell. This lake was larger than any freshwater lake in existence today. And it covered from Great Bear to Lake Athabasca at one time, and essentially, the basin of Great Slave Lake. And it blanketed this area with silts and clays. Silts and clays that are considered to be thaw unstable, meaning that it is the ice contained within the sediment which is holding the material up, and when it thaws, as it's released, it will not have the same bearing capacity or load capacity that it has when it's frozen. It's essentially unstable. Here you see, it's this gray terrain around here showing you the thaw unstable clays and silts in the Yellowknife area, and we'll see more of this in a moment. So what is this stuff like? We already saw some temperature curves that trying to give us an indication of what permafrost is like. What does it mean to have thaw-unstable permafrost? So I think thaw-unstable permafrost is like ice cream. Some people have told me it should be like Rocky Road, but I'm going to use vanilla. Okay? So if we look at these temperatures, you look at cold ice cream. I don't know about you, but I get the ice cream out of the freezer and I dig right in and my spoon bends. I have to wait for this stuff to warm up before I can eat it. Well, it's at -5. It's at -5 degrees. -5 degrees and colder. It's the ice contained within the matrix of the cream that holds this block of ice together that makes it difficult for me to eat. And it's what gives it its strength, just like permafrost. But the permafrost that we've seen in Yellowknife is warmer than that, -0.5 degrees, 1.5 degrees in undeveloped terrain. Well, it's frozen, but it's not well frozen. I can put my spoon into this, and I can eat it right up. Now, within developed terrain, as we saw, the temperatures are more like -0.5. So what's happening? Those well-bonded ice crystals are thawing a little bit, either because of the sugar or because of, in this case, because of the silts and clays that are there as well, and it's getting soft. So it doesn't have the same bearing capacity as it begins to warm. And in this case, it's because of the infrastructure and the changing environment that we've seen in the area. So I don't know about you, but I've seen, if I go around looking at lampposts and so forth and this sort of thing, and they've gone down. The near surface is thawing. And you see that the introduction of infrastructure increases that active layer, that layer that was freezing and thawing each year. In addition, it also can cause the top of the permafrost to thaw. These are the warmer temperatures you see going off here. This is a result of the infrastructure. As well, we'll see that the effect of the permafrost at depth is also warming. What does this do? It results in settlement. Results in settlement of the entire landscape and the infrastructure, like this. So this is, and the fact that the infrastructure, the building may settle more than the land around it. That's differential settlement, different settlement, okay? It's why we get bumps on the road. Now, as I said, in addition to the thawing here, we also see warming of the permafrost itself. As I said, it's not undeveloped terrain. It's developed terrain more like -0.2 degrees. We've seen continued thawing as a result of the infrastructure and warming of this so-called frozen ground. And in fact, even after site abandonment, the permafrost is still here. It's still frozen. It's not about waiting for the permafrost to disappear. It's about the transition of this warm permafrost, which is occurring right now. That's what's important. So people were hoping to see slides of bumpy hills and roads and so forth. So I thought, well, we better make sure that we have them. So these are just examples that we'll see. And in fact, as you can see, it's why I might have called it Rocky Road. And what I'd like to do now is introduce a little bit of science to go with this, not just talking about ice cream, but talk about reality. I'll start by going to space and explain that what we're going to look at is the subsidence or differential changes that have occurred around Yellowknife from satellites. In this case, synthetic aperture radar. It's RadarSat. Basically, there's a satellite that is going over Yellowknife every 28 days. And if you're lucky, you'll get some imagery, and we can take a look at changes over time. So what we did in the summer of 2010 is look at a 4-month period of the changes of the surface of the terrain in Yellowknife over 4 months, the summer period alone. And we came up with this map. This is available both on site at the NWT, Climate Change. I believe there might be a copy on here, I'm not too sure, but it is available at a number of sites through the government of Northwest Territories. And the GSC, we publish this as part of Natural Resources Canada. So what you see here, the blue is stable. So there's a lot of stable ground. In fact, there's like 90% of it is stable. But we also have, and I'm going to focus on just 2 things here. Low downward displacement, land that has gone down over a 4-month period between 1 and 3 centimeters, and land that's gone down between 3 and 6 centimeters in that same time. So the red areas, which we refer to as moderate, will be the areas that have gone down the most over that 4-month period. Michel Allard indicated that one of the most important things that we can do in understanding permafrost is to understand the superficial geology. And whereas there is a superficial geology map published in the 1970s, it had its issues in terms of being updated. So I took about 200 air photos home over the weekends, and I mapped the superficial geology for Yellowknife so that we could take a look at this. And the pink is bedrock. And you will note that there is not movement on bedrock. Great, there shouldn't be. It's stable. In fact, according to this, it's 96% stable. Why it's not more? It's simply because that's the resolution that I can be capable of mapping. There may be peatlands, there may be clay terrain on the rock, but it's too small to really see. So what we found was that bedrock was 96% stable. That's all very fine, but in fact, what's important to look at now, the next thing we should look at are those clay sediments. These are the thaw-unstable glacial-lacustrine silts and clays. They represent 30% of the Yellowknife area. 30% of Yellowknife is underlain by the silts and clays. And it's not a coincidence that the road networks follow the clay terrain. Why? Well, if you want to put in piped water and sewer, are you going to blast the bedrock all the time? Or are you going to work on unconsolidated sediments where you can dig? That's what you do. It is easier to work with, and essentially, the clay terrain is unavoidable. So the fact, interestingly enough, most of the settlement issues that we have in Yellowknife are related to the clay terrain, by virtue of the fact that a lot of the infrastructure is on that clay terrain. Another one that I'd like to point out then are the organic deposits. They only represent 5% of the Yellowknife area. It's avoidable, and in fact, it should be avoided. It's not always avoided, but it ought to be because it is the most unstable terrain. And I will show you an example soon enough of the area around the Legislative Assembly, which is on peat, and show you examples of what happens when you actually develop on peat. So a simple enough recommendation is avoid peatlands as number 1. And lastly, of course, these big yellow areas. This is the sandy areas, and I'll say founding forefathers for Yellowknife decided in their wisdom to move Yellowknife from Old Town up onto the hill. And they went on to sand because it was thaw stable, not like our ice cream. And in fact, you see there's very little, there's no yellow, there's no other yellow or no red in this area. It is relatively stable terrain, a nice gridded road network. Now in contrast, we'll go over to the airport and we'll see there's actually appears to be some displacement, downward settlement going on at the airport. Why is that? So I'll introduce that in a moment, but I'd just like to add to this then added municipal zones for Yellowknife. And again, to point out, the airport, the green is essentially residential, this is mixed-use area, and this is the industrial zone. So with that, I'm going to give you 5 examples and then go through those, and I should be done after that. The first one is Fritz Thiel Park. It's a baseball diamond, and interestingly enough, I need to give you a bit of history. It was originally a lake, and the lake was then filled in. It became landfill, and then after that, it was made a baseball diamond, very sensibly too. It did not contain permafrost. That area is essentially this one here, the blue. There's the baseball diamond here. It hasn't actually settled or moved. This, however, this is the clay terrain that you see around it in purple. And what the area I'm going to focus on here shows the significant downward displacement, which is right along here. And hopefully Steve Schwartz doesn't mind me mentioning that he lives right over here. I don't think he does. And this is the fence line as it looked in 2011. And just imagine, it's like thawing ice cream. Notice a body of water here as well. Water has such a significant effect on permafrost as a warm source. And then in this summer, repairs were underway on this section of the road, and in fact is filling in this to ensure that the water is moving away. Second example is the industrial area. This is not the house on the ice cream. This is a building on permafrost, which has gone down about 1 meter because it's basically a warm foundation on permafrost. The example that I'm showing here is the Decho Boulevard right here. It is on permafrost. There is ice at depth, and it was reconstructed in 2011 because of the differential subsidence. Interestingly enough, and I'd like to point out, that we saw water flowing down this area, and Michelle had pointed out the importance of snow. And we followed this water, and interestingly enough, it wasn't very effectively going through culverts, but going under the road instead. We followed it up 1 mile to the airport, which is where the snowbank, where the snow dump was. So drainage control is very important. The next example is Forest Drive. Here we see subsidence very specific to this area here on clay terrain, which was identified in 1971 specifically as Area B, right here. 5 boreholes were drilled, and it was encountered, of course, glacial lacustrine sediments. Notice soft frozen 2-centimeter ice lenses. These are just examples of 30 centimeters of differential subsidence that has occurred since the last time this road was paved, and the wobbliness of the fence since it was last put together, which is gone now. Just a note on the report from 1971 on degradation of permafrost. This area will be subjected to subsidence and could result in settlement problems for structures, utilities, and roadways. It is anticipated that the order of settlement would be on the order of at least 1 to 2 feet. Now, interestingly enough, it was 10 to 15% ice. I would have estimated 2 to 4. The Legislative Assembly, like I said, it's always best to avoid development on peatlands, but nevertheless, now and then, this doesn't happen. In 1990, this is a photo I took in 1997. I just mentioned one of the problems associated with permafrost in Yellowknife is when the Queen shows up. Because when the Queen shows up, we want to make it look nice, and it is the Prince of Wales Heritage Centre. Chances are she's going to go visit her son's favorite place in Yellowknife. So they had to pave it. And of course, the embankment was built, the insulation was put down, and it was paved, and it was indicated that if we do this, it should last about 15 years. 13 years later, there's 50 centimeters of differential subsidence on the road. It was reconstructed in 2010, regraded, and leveled in 2010, and we measured 30 centimeters of rotational subsidence in 3 years, 10 centimeters per year, right here. And just to point out, 40 to 50% visible ice, and these are the temperatures barely below zero back in '98. All 5 boreholes that were drilled did encounter permafrost. Settlement can be expected as the permafrost thaws, the initial settlement as the ice melts, or ice cream melts, as I like to think, long-term settlement as the silt and clay consolidates. The last example is the Yellowknife Airport, which was interesting, as I mentioned, because it was on sand. And yet we saw subsidence occurring on the part of the runway over that 4-month period in 2010. We went back to report from 2004 and found that, in fact, it was a known settlement area where near-surface silts and clays were known to occur. So in conclusion, as I said, I would have two parts with specific points. This part being that really in undertaking an understanding of permafrost and the changes of permafrost in communities, a review of the historical and geotechnical knowledge that is in place is necessary, and even documentation of the changes as they're occurring. For example, if you're making changes to infrastructure, that it's well documented. A concerted science and engineering effort towards understanding the changing state of permafrost. And lastly, integrated adaptation plans. That means that you're looking at the range of infrastructure together, not buildings separate from roads, that are separate from driveways, that are separate from pathways and so forth, but it's an integrated plan for infrastructure in discontinuous permafrost. Thank you very much.